Hi there, this is Math 148. We're moving on to section 12.2. It's a beautiful sunny day, and just for effect, I have added the sound of lawnmowers in the background, so I hope you appreciate my Foley effects. I'm kidding, it's just lawnmowers. Alright, so let's review what we have so far. Suppose I have the integral of x to the fourth dx. What does that equal to? I'm giving you a beat. Yes, you are correct. It is 1/5 x to the fifth plus our constant. Okay. You're saying, let's try this other one. What if we have the integral of u to the fourth du? What does that equal to? 1, 2, 3. Do you have an answer? It is 1/5 times u to the fifth plus a constant. That's a plus a constant. So my point is, it doesn't really matter what this variable is. It could be x, it could be u, it could be a smiley face, it could be the letter v, it could be all sorts of things. This rule remains the same. I bring this up because it will come up in a moment in this section 12.2, which is power rule. Power rule for integration. So here's the basic problem. Suppose I told you we had a function, f of x. I'm going to start with the function so you can see this one coming. Was something like this. 2x squared plus 1 cubed plus 40. And suppose this was test number 1 and I said find the derivative of f. Well, many of you at this point, you're feeling pretty confident. The answer is 3. Remember the 3 comes down in front. Times 2x squared plus 1, subtract 1, that becomes 2, multiply by what's inside. I'm just doing the derivative. This is nothing new. 4x plus, the 40 goes away, 0. Okay? So, our answer would be 12x times 2x squared plus 1. Okay, well suppose I had the integral. Oh, I'm running out of space. I'll just do it here. Suppose I took this integral, blue, integral of 12x times 2x squared plus 1. That's squared, sorry. Squared. How would you find this integral? So look at it, just stare. Right now, there's a big messy page, but focus all of your attention right here. How would you do this integral? It's not nearly as easy as this pretty integral, but we can do it. And you know that the answer is this one, because we just took the derivative. Remember, you have a function, you take the derivative. If you take the integral of the derivative, you get the function again. So it's like going backwards from a derivative. So the question is, how are we going to take this integral and immediately see that this is the function, or at least with some effort, see that this is the function? And this is what all of section 12.2 is about, power rule. Feels kind of good to be powerful and ruling, but maybe it doesn't feel so good to be doing it with derivatives. So here's an example. Sorry, I'm getting so many emails. I'm pretty popular. Everybody wants to know about this power rule. Question number 3. The integral of x squared plus 3 cubed times 2x dx. This is your problem. This is from the 10th edition textbook, and I am looking on page 762. Here's the problem. So this is pretty messy looking, and initially you guys might not like the way it looks, but I'm going to show you this power rule trick, how to make it work. So the thing you want to focus on is we have these parentheses with a power raised to something. So your whole attention should be focused inside these parentheses. And we're going to do this. I call it a trick, but it's more just a method. It's more fun if you call it a trick called I used to call it substitution. I don't know why they don't use that clever turn of phrase, substitution. So I look inside these parentheses and I say, well, I don't like this x squared plus 3, I say out loud to my dogs. I'm going to let u equal x squared plus 3 because having this big thing inside the parentheses is very messy. So now, just follow along here. You don't know why we're doing this, but I will show you. Du, take the derivative of both sides. Okay, why are we doing that? Just follow along. Okay, the derivative of this side is 2x, right? 2x plus 3, that goes away. Dx, derivative of x. Now, I'm being very formal here. I'm putting the dx on this side. Technically, you could say du dx equals 2x, like the derivative in terms of u in terms of x. And then you could move the dx over there. I'm just kind of taking a little quick shortcut. So why did I do that? I will show you. So now this same messy integral, I'm going to use u substitution. Now the x squared plus 3, I can just write that as a u. Yes, I can. And then put a 3, u cubed. And this part, see, this is the beauty. Aha! That 2x dx just perfectly works out to du. And now we're home free because you already told me on this first page that the integral of u to the 4th du is just 1 over 5. So in this case, we do our same rule that we learned in section 12.1. We add 1, u to the 4th, and then take 1 over 4. Where's our constant? There it is, you get a cookie. And then we plug. You can't leave it in terms of u. So you have to plug it back in when you're done. So now we take this and we put it back. So our answer is 1/4. We put this back. X squared plus 3 cubed. No, 4th. What is that? No, 4th. There, sorry. 4th plus a constant. Like this. And with all of these integrals, you can always do a derivative to check your answer. So I'm going to check my answer. I'm going to show you how that works. Checking, checking. So suppose I said, well, I'm claiming that my function is equal to 1/4 times, where was it? X squared plus 3 to the 4th plus a constant. So I'm going to take the derivative and see if that equals the integral that was given in the problem. So it's 4 times 1/4. I'm speedy derivative today. Cubed, right, times 2x times the derivative of a thing that's on the inside. Derivative of a constant goes to 0, so that whole thing, 4's cancel, equals 2x times x squared plus 3 cubed. You could take the derivative dx, like that. And this was, in fact, what was inside the integral. See? Right there, this thing. So when you check, you're looking to check to make sure that this is the derivative, that part with the dx. So that was question number 3. You're thinking, wow, that was so complicated. That was only question 3? Yes, but we're going to do the exact same process for all of these questions. So it's just more of the same as you move along. Here's another one, question number 5. We have, make sure I write these down correctly, 5x cubed plus 11 raised to the 4th times 15x squared dx. So again, you look at this and your brain is going la, 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 like that, but focus on this inside this parentheses, that you have something raised to the 4th up here. Look inside and you say, okay, that's where I'm going to focus my attention. I'm going to let u equal this inside piece, 5x cubed plus 11. So we're going to just give this a shot, see if it's going to work. I bet it's going to work because it's in this section. Take the derivative again. Take the derivative of this. It's 15 x squared. That goes away because it's plus 0. And then I'll write dx. Ha ha! Right? So obviously these problems are set up to make this work out particularly well. So this integral, right here, that one, we can rewrite this. This whole piece, the 5x cubed plus 11 to the 4th, can be rewritten as u to the 4th. This piece, 15x squared dx, right that, can just be du. And now we can solve it. We say, well, that's just 1 over 5 times u to the 5th, because you're adding 1, plus our cookie, constant. So I'm going to plug the u back in. So you can't just leave it in terms of u. So plug u back in. I'll go back to red. And you get 5x cubed plus 11 to the 5th plus a constant. And that's your answer. So it's complicated in the sense that you have to do this u substitution. But once you get to this part, it's not really a lot more. So here's another one for you. Question 11. You're thinking, well, probably some of you were thinking, well, wasn't that handy that this worked out exactly perfectly for our derivative? And what happens if it doesn't work out perfectly? Calm down. I'm here. I have an example. So There's that was the worst looking integral. Okay. 7, this is question 11, 4x minus 1 to the 6th dx. It doesn't always work out perfectly, but there are tricks to help smooth it along. So we're looking at this, and again, you're focusing on this inside the parentheses. You see that this is something raised to the 6th, so you look inside. Are you looking? All right, let that be the u. It's all about u. 4x plus 1 is inside the parentheses. Take the derivative of u. You get 4 times dx, right? The derivative in terms of x. So you think, well, that didn't work out because I have a 7. I don't have a 4. Kate, that didn't help. We're stuck. You email me at 1 in the morning, and I say this. Well, I guess I'll use yellow. So here's the trick. We want it to look like this, right? We want it to look like 4 times 4x minus 1 to the 6th dx. That's what you really wanted the problem to say, and you're wondering if it's a typo, but it's not. There's a 7. So here's how we deal with this. We just say, well, that's the same thing as 4 times, you put a 1 over 4 like that. You trick it with a constant. So I say, well, if I say it's 4 times this thing, and then I also divide everything by 4 at the end, then it's essentially worked out. So do you see? I wanted a 4, so I put a 4 in there. I multiply it by 4, but because I actually multiplied everything by 4, I also have to divide everything by 4. But I can pull this out into the front. So this equals 7 times 1 over 4. I'm just rewriting the actual equation. I haven't changed anything yet. 4. Have not really done anything. Just continuing to rewrite it till I get the form that I like. Ah, I like this form. Do you like it? Do you see why? Because now this piece, this is equal to the integral. That one's u to the 6th, and that 4 dx, that is du, like this. And in the front, remember you can factor out a constant, so that's 7 divided by 4. Easy. Now we're home free. Check this out. You're going to like this. So this is 7 over 4. Now we're just going to take this integral. Now, finally, we can take an integral. So this is u to the 7th, because you add 1, and then 1 over 7 plus a constant. They cancel. I was excited. I was excited when they canceled. I'll be honest. It makes me happy. Okay, so now we have to substitute back in with the u. Here's our u. Don't lose it. Sometimes I put a box around it so I can find it again. And that becomes 4x plus 1, plus 1 to the 7th plus a constant. I'm going to rewrite that so you can see it again. Equals 1/4 times 4x minus 1 to the 7th plus a constant. So check out these problems, do a bunch of them. I'm going to put one on the test that is exactly one from your homework, so just do them all and you will be well prepared. So again, focus in here. Let that be you. It's all about you. Let me know when you get stuck.